Oscilloscopes. What are they and why are they so useful? I'm an electronics engineer, and as an electronics engineer, this is my best friend. Well, that too, but this is my engineering best friend. An oscilloscope is an instrument that draws a graph of an electrical signal, and this graph can tell us a lot of things about that signal, such as the time and voltage values of a signal, the frequency of an oscillating signal, the frequency with which a particular portion of the signal occurs relative to other portions, whether or not a malfunctioning component is distorting the signal, how much of the signal is DC or AC, how much of the signal is noise, and whether that noise is changing with time. So, in other words, it tells us a lot. At the most basic level, the graph of an oscilloscope shows us how an electric signal changes with time. Who uses oscilloscopes though? Engineers and scientists use oscilloscopes to test, verify, and debug their circuits. Personally, as a circuit designer, mastery of this equipment is so incredibly important. Cool. Today I will be showing you how to use the Rohde Schwarz RTB2004 Oscilloscope. For quick reference, here are a few different features that make this particular piece of equipment so cool. Now before we begin, I want to give you a quick tour of some of the unique features this oscilloscope offers. We have a 10-bit ADC, 10M memory, 10.1-inch touchscreen, that is a whole lot of 10. We have a logic analyzer, a protocol analyzer, waveform and pattern generator, digital voltmeter on top of the oscilloscope features.
Alright, now for the part we've all been waiting for. How do we use it? To give you a crash course, let's start with the basics. The vertical or the y-axis shows us voltage, and the horizontal or the x-axis shows us time.
You can adjust the horizontal position and scale very easily using these knobs. And the same can be done for the vertical position and scale. Here we have a sine wave that is pretty much unrecognizable because of the settings. I will be adjusting the settings so that we can see it properly. Sometimes it'll be necessary for you to go back and forth on these a little bit in order to get the best view of the wave that you're trying to capture. There it is. It looks totally different than what we were first looking at. So to recap, the vertical section is going to allow us to adjust our vertical scale, which here we can see is in volts, and the horizontal section is going to allow us to adjust the horizontal scale, which is in time. Something really cool about this particular oscilloscope is that it actually also has a function generator. So let's click on apps really quick and see what else is included with this particular oscilloscope. Whoa, I love this section because look at everything we have. The scope is one of the apps. We also have quick measure, we have FFT, we have Bode plot, we have a voltmeter, we have counter, we have probe adjust, which allows us to adjust our probes, and we have my favorite sections, other than the scope of course, function generator and pattern generator. So let's go ahead and click on the function generator for now. For the function generator, we have a few different types. Here we can see DC, sine, rectangle, pulse, triangle, ramp, arbitrary, exponential. Here we can also adjust frequency, amplitude, offset, duty cycle if applicable, symmetry if applicable, etc. So it's actually very intuitive and the touchscreen helps a lot. Now we're going to move on to the pattern generator, but first I want you to take a look at the different things that we have available here in the menu, and you can access them just by touching on them on the touchscreen. It is super cool. So let's click on the pattern generator. Now for the pattern generator, we're going to be looking at a different section for these outputs than we did on the function generator, but it provides a very good legend here of exactly where to look for these signals. When it comes to the square wave, this little guide right here tells us that we can find the rectangle at PO. So let's go ahead and probe at PO and see what it is that we find there. Now let's just quickly look at some of the different patterns. Here we can see counter, we can see UART, we can see SPI, I2C, etc. And we can also see here that the guide does change accordingly. Super easy. Cool, but signals won't always be so well behaved as this. Sometimes we want to catch them at the moment they change. For example, maybe we want to catch a signal as it rises or as it falls. And sometimes this may happen a little bit too quickly, or maybe we won't even know that it's coming, which is why we want to set something called a trigger. The name is pretty self-explanatory. We essentially want to wait until the signal triggers a response out of the scope. The scope monitors the incoming signal and waits for the voltage to rise above or fall below a threshold that we can set. Once it detects it, the scope will capture and display the waveform. Triggering is very useful when you want to stabilize a repeating waveform on your screen, or also if you want to have a single shot capture. Let's do a quick little tour of the trigger section. The trigger button will open the trigger menu, and source will change the trigger source. As you can see here, it will also change color, and this will match the color of the associated channel. The run and stop button will do just that. Green means we are running and red means we are stopped. But what is it actually stopping? Well, it is starting or stopping a continuous acquisition. Pressing the single button will execute a single shot acquisition. The trigger level can be changed using this knob, and if you actually press it, then it'll automatically set it to 50% of the signal amplitude. The little label that says triggered will actually light green when a trigger occurs. Now let's move on to the auto or norm section. When norm is enabled, the scope will only acquire a waveform if a trigger actually occurs. If no trigger occurs, then no waveform will be acquired, and only the last waveform, if there is one, will be displayed. For this, if you want to see what's going on, you can press force trigger and it will manually show you the waveform without actually having the trigger event occur. When auto is enabled, you will see the waveform trigger after a given time interval, even if the trigger event that you set has not actually occurred. This will just allow you to see what's going on in an easier way, but both of them have their different scenarios where you might want one over the other. There are a few different trigger sources available, such as channels 1 through 4, which allows us to use the analog channels as trigger sources. We have 16 digital channels available as a trigger source. There's also the external trigger input, just in case you might need it. There are a few different trigger types available, but the most common are actually edge and width. So for this, I will be discussing edge trigger. The edge event will occur when your signal passes a specified level, and you are actually able to set that level using your trigger knob. Now, what you can also set is whether you want it to trigger on the rising edge, on the falling edge, or on either one. For this example, I will be setting mine to a rising edge, and I will actually have my signal off, and I will be turning it on in order to capture it with the oscilloscope trigger. And there it is! Now that we have this waveform that we triggered, I think it's a really good segue into measurements. So let's measure some of the things that are going on in this waveform. Many oscilloscopes already have functions that make these measurements much easier. Here's a quick tour of what we have readily available. We have peak-to-peak measurement, period, frequency, rise time, fall time. We can see there are many more measurements readily available for the vertical section. We have some for the horizontal section. There are just so many. You don't really necessarily have to make your own if something already exists in here. Thank you. Now let's mess around with setting some of these. I'm going to ask for a frequency measurement, rise time. We can see that those measurements are starting to appear here at the bottom. We have the frequency, which is about 10 kilohertz, and then we have the rise time. Now let's add one more. We're gonna add peak-to-peak measurement. And again, we can see it populating down here at the bottom. So now we have EPP at about 3 volts as well.
If you're an electrical engineering student or trying to get into electronics as a hobby, I really hope that this was able to help you. Let me know if you have any questions, or let me know if there's anything else about this oscilloscope or oscilloscopes in general that you would like me to cover. It has so many more functions, and I would love to get into it, so let me know. Now it is time for me to go back to tinkering in my lab, so see you next time.